Sairam to you all, dear children. Today again I will be continuing with the same chapter entitled Mass and Density, Class 6, Subject Science, Part 3, Chapter 7. So before I discuss with you all Part 3, let us recall what we learned in Part 2. In Part 2, we discussed about the working of a physical balance, right? And also the common balance. So what did we learn from the balances? The weight, the mass of a body, the body whose mass has to be found is placed in the left pan, and equivalent weights are placed in the right pan. So when the weights in the right pan matches or tallies with the mass of the body in the left pan, the pointer will be exactly at 0 on the scale and it will not dangle. So it will be at one fixed position vertically. So that point is called the balancing point. Okay. And common balance also works similar to the physical balance, but physical balances are used in laboratories. Common balance is used by grocers, vegetable vendors. Okay. Now, let us discuss part 3 in detail. Measurement of weight. So today's topic is measurement of weight. The weight of a body is measured by a device called spring balance. Spring balance is invented by Robert Hooke. So Robert Hooke is the scientist who invented spring balance in the year 1678. A spring balance consists of a spring enclosed in metal case. There is a slit along the length of this metal case. Measurements are marked on one side of the slit. A pointer moves on this scale. The upper end of spring is attached to the case. A hook is fixed to the lower free end of the spring. Now, let us understand the working of spring balance. An object whose weight is to be determined is suspended by the hook, which you will be seeing in the picture. As the gravity of Earth pulls the object downwards, the spring will be stretched. The reading of the pointer on the scale gives the weight of the suspended object. The SI unit of weight is Newton. The SI unit of weight is Newton. Okay. So SI, again I repeat, what is SI stand for? What does SI stand for? SI stands for Systems International. So the SI unit of weight is Newton. Okay. Now, here is the picture of spring balance. Right? See, there is a hook attached to the spring, and when an object is hooked to the spring balance, the spring stretches, right? Understood? So here is the scale which reads the weight of a body or an object. Now, the space occupied. Now let us understand what do we mean by volume. The space occupied by an object is its volume. The space occupied by an object is its volume. Matter is also measured by its volume. Matter is also measured by its volume. So the space occupied by matter or object is its volume. Mass and volume are interrelated. Now, different materials with same mass may have different volumes. So let us consider this example. If we consider 1 kg of iron and 1 kg of cotton, then cotton has more volume than iron. Why? Why is it so? Why do we say that cotton has more volume than iron? This is because cotton occupies more space than iron, but their mass is the same. Okay. The mass of iron is 1 kg. The mass of cotton is also 1 kg, but cotton occupies a larger space than iron. Now, different materials, again here, there is one more thing. Different materials with same volume may have different mass. That is also possible. Different materials with same volume may have different mass. Example, take two identical glasses. Fill one with sand and other with water. Then what happens? A glass filled with sand is heavier than the glass filled with water. Okay, so masses are different, but their volume is same. Okay, masses vary here. So when it becomes necessary to compare masses of different objects with same volume, the densities of these objects must be found. The densities of these objects have to be found. Now, let us understand what do we mean by density. What is density? Density of any object tells us how closely the molecules in that object are packed. So, if the molecules in an object are very closely packed, then the density of that object will be more. The object will be heavier. Now, if the molecules in an object are loosely packed, its density is less. The object will be lighter. The object will be lighter. So, if the molecules in an object are loosely packed, right, density is less. The object will be thereby lighter. Its representation in the form of formula is density equal to mass by volume. Mass by volume, the SI unit of density is kilogram to the power of minus 3. The SI unit of density is kilogram to the power of minus 3. Okay. Now here is the summary of the video. Space occupied by an object is called volume. Space occupied by an object is called volume. Matter is also measured by its volume. Different materials with same mass may have different volumes. Different materials with same volume may have different mass. Density is equal to mass by volume. Here are the questions related to the video. First question is, what is volume? Second question is, how mass and volume are interrelated? Third question is, explain density in detail. Fourth question, explain by means of an example when density is more. Fifth question, different materials with same mass may have different volumes. Explain in detail. Explain in detail by quoting example. Okay. So saying, let us call it a day. Thank you. Sai Ram.